Problem number 3. 6 distinct positive integers are randomly chosen between 1 and 2011, inclusive. What is the probability that some pair of these integers has a difference that is a multiple of 5? Alrighty. Well, this is definitely a problem that looks harder than it really is, at least at first glance. But start by thinking about if 1 is in your list, what are some of the possibilities for the other numbers that you could have in your set of 6 positive integers that would give you a difference that's a multiple of 5? Okay, so if we have 1 in the list, then 6 would give you a difference that's a multiple of 5, or 11, okay, and so on. Okay, you could come up with a whole bunch of them, and right up to what, 2011. If you take the difference between 1 and 2011, and you'll get something that's a multiple of 5, right? So any of the numbers, it looks like every fifth number will give you something, will give you 2 numbers that you could subtract and get a multiple of 5. Okay, so let's say now that 2, say 2 is in your list, then 7 would be a potential number, or what, 12, and so on up to what? Well, it looks like these are all 1 more, but 2012 is outside of our range here, so let's subtract 5 from 2012, so 2007 will be the last number, or the biggest number that we could find, that where the difference between any 2 numbers in these sets in this set gives you a multiple of 5. Okay, so let's keep going. If we had 3 in the list, then we'd have 8 and 13 all the way up to 2008, right? Those would all give you, if you took any two of these numbers, you would get a difference that's a multiple of 5, right? 4, 9, 14, all the way up to what, 2009. We'd have 5, 10, 15, all the way up to 2010. Okay, and that basically takes care of all the numbers. That categorizes all of the numbers between 1 and 2011. Okay, so the numbers that we choose have to fall into one of these categories. Okay, they have to be in this set of numbers, starting with 1 all the way up to 2011, every 5th number. Okay, and this is again every 5th number, but starting with 2. Here's every 5th number starting with 3, every 5th number starting with 4, and every 5th number starting with 5. Okay, so we have 6 distinct positive integers that we're choosing, and we've got 5 categories. And so even if we choose 1 from each category, the 6th one then has to come from a category that we've already chosen. And this is something called the pigeonhole principle. Pigeonhole principle. Okay, and that just says that you can think of it like pigeons. If you had 5 pigeonholes and 6 pigeons, then you have to have one of the holes filled by 2 pigeons. Okay, so that would say that if we have 6 numbers and we have them categorized into 5 groups, then we have to have at least 2 numbers that are in the same group. And if we have 2 numbers in the same group, then we're automatically going to be able to take those 2 numbers, take the difference of those 2 numbers, and it will be a multiple of 5. So that gives us a probability of 100% that we're going to be able to take two numbers. There's going to be some two numbers in the set of 6, where you can take the difference and it's a multiple of 5. All right. So there you go.